Off the coast of Africa, on the island of El Hierro, the foothills of the volcanic island drop straight down to the abyss. These waters are home to a little-known marine mammal, the Blainvilles beaked whale. Similar in appearance to dolphins, this toothed whale with a curved beak spends most of its time underwater. Males have a highly distinctive appearance with overarching jaws and 2 forward-facing teeth. Until the end of the 20th century, our only knowledge of these animals came from beached or dead specimens. 20 years ago, scientist Natasha Aguilar discovered that several dozen whales sheltered in the bays at the foot of the volcano rather than living out at sea. This meant she could access them more easily, allowing her to catalogue and name more than 50 individuals. In order to learn more about their sensitivity to noise pollution from ships and military activity, she plans to equip the whales with highly sophisticated diving recorders called Dtags.
The Dtag is attached to the animal's back with suction cups and goes with the animal on its deep dives. With it, we can find out how they vocalize to find food, how they communicate amongst themselves, how they move, and even how much energy they consume searching for food.
These revolutionary markers should allow Natasha to track the abyssal adventures of these mysterious whales. But first, she needs to attach them to her elusive subjects. Natasha has developed a cooperative technique. Land-based lookouts scan the water to see the whales coming up to breathe.
Chloe,
What?
I have a group of animals.
What can you see?
There are 2 Blainvilles,
Okay, 2 Blainvilles,
2 adults.
2 adults.
Red, ground base calling.
Yes, red receiving.
Okay, Natasha, we have a group of animals, 2 Blainvilles.
Okay, we're heading over.
As soon as there is a sighting, Natasha and her partner Patricia have fewer than 5 minutes to place the tag while the whales surface. Success. A male has been tagged. When it surfaces, the tag signals its location to Natasha's team, who track it day and night, on land and at sea. After more than 24 hours, the tag is released, and Natasha can recover it from the water. Thanks to the precious data gathered by the tag, Natasha can quickly reconstruct the Blainville's beaked whale's movements and sounds with incredible precision.
Before it goes under on a feeding dive, a Blainville's beaked whale rests on the surface for 5 minutes, filling its body with oxygen, because they store oxygen in their muscles. It dives, and at around 1,500 feet, it starts clicking to echolocate for food.
Thanks to the Dtag, it's the first time ever that we've been able to listen to these whales and shed some light on this dark world.
When the whale comes across the prey that it wants, it raises the frequency of the clicks. It goes from an acoustic photo to an acoustic video, which allows it to follow its prey more precisely and catch it. The whale surfaces when it has eaten enough or when it no longer has enough oxygen. It only stays at the surface for 2 minutes before it starts a series of recovery dives at depths of less than 650 feet.
The whales actually rest at a depth of 650 feet, taking several 20-minute naps to recover before their next deep dive to feed. While hunting, the male whale dove to depths of over 3,000 feet, more than half a mile. That's 1,000 feet more than the sperm whales seen in the Gulf of Mexico. But around the same volcanic island, Natasha noticed the presence of another similar beaked whale species, the Cuvier beaked whale. It varies from its cousin by its larger size and its more prominent melon. As part of her study on the impact of sound pollution in the ocean, Natasha also hopes to place tags on these elusive animals. The problem is that once they have surfaced for less than a minute, the Cuvier beaked whales disappear for anything from 30 minutes to 2.5 hours, which suggests they have remarkable diving capabilities. The Dtag will be able to reveal all if Natasha manages to place it.
There it is. Here in El Hierro, we've tagged Blainvilles beaked whales and Cuviers. But the tags slip. They have algae on their skin, so the tag won't stick to their bodies.
In El Hierro, the Cuvier beaked whales are keeping their maximum diving depth secret for the moment. But their diving duration is similar to that of a much better-known animal, the sperm whale. The sperm whale can also dive for up to 2 hours. Its whole anatomy is designed for diving for long periods. With each breath, we humans replace only 15% of the air in our lungs, while sperm whales are able to renew 90% of their breath. Its muscles are rich in oxygen-carrying proteins and can store 10 times more oxygen than humans. As soon as it leaves the surface of the water, the sperm whale's metabolism slows down to save oxygen, and its blood is concentrated on vital organs like the heart and its enormous brain, the largest in the animal kingdom. Its chest cavity is flexible, so it doesn't snap when the pressure mounts. Its huge head, a third of its body length, contains a yellowish wax called spermaceti. It is believed that whales can vary the density of this substance at will. By restricting the blood supply, the spermaceti solidifies, acting like a weight, and allowing the whale to dive deeper and with less effort. When it resurfaces, the sperm whale reheats its spermaceti, causing it to liquefy until it is lighter than water. To avoid decompression accidents in the bends, the whale is able to collapse its lungs while still sending oxygen to the brain. So the sperm whale can stay underwater for up to 2 hours. But the maximum depths that it reaches when it dives remain a mystery.